Here's a quick brain teaser. Can you add two irrational numbers and get a rational one? Or multiply two irrationals and still end up with something irrational? Not so sure? Don't worry, you're not alone. In this lesson, we are diving into what really happens when we add, subtract, multiply, or divide real numbers, especially when we mix the rational with the irrational. So get ready, because some answers will make total sense and others might just surprise you. Before we jump into operations, let's do a quick refresh. Real numbers are made up of rational numbers like 3 minus 2 or 5 divided by 4 and irrational numbers like square root of 2 or pi. Basically, if it has a spot on the number line, it's a real number. And now, we are going to test what happens when we add, subtract, multiply, or divide these numbers. Ready to explore? Let's go! Let's start with the familiar team, rational numbers. The cool thing? Rational numbers are super cooperative. Add two rational numbers, you get a rational number. Subtract, still rational. Multiply or divide, yep, rational again. As long as you're not dividing by 0, the result is always rational. That's called being closed under operations. You stay in the same number family no matter what you do. Easy to work with, right? Now let's bring in the irrational numbers and things start to get a little wild. Add square root of 2 and square root of 3. That's irrational. Multiply square root of 2 by square root of 3. Still irrational. But wait, multiply square root of 2 by itself. That gives you 2. And 2 is rational. So here's the surprise. Irrational numbers are not closed under operations. Sometimes the result stays irrational and sometimes it flips back to rational. In other words, you can't always predict the outcome just by looking. So what happens when you mix a rational number with an irrational one? Let's try a few examples. 2 plus square root of 3 still irrational. 5 multiplied by square root of 2 still irrational in general. Rational plus or minus irrational. Irrational. Rational times or divided by irrational. Usually irrational. Basically, the irrational part takes over the result. So unless something cancels out perfectly, you'll end up with an irrational number. Now here's where things get interesting. Some combinations might fool you. Try this, square root of 5 plus minus square root of 5, that gives you 0, a rational number. Or square root of 2 multiplied by square root of 2. That gives 2, also rational. So here's the key. Irrational plus irrational can be rational or irrational. Irrational times irrational can also be rational or irrational. There's no shortcut. You have to check each case. So with all this mixing and matching, you might be wondering, do the basic rules of arithmetic still work? The answer is absolutely. Whether you're using rational or irrational numbers, these laws always apply. Commutative law, a plus b is the same as b plus a. Associative law, add a and b first, then c, or b and c first, then a. Either way, the result is the same. Distributive law, when you multiply a number with a sum in brackets, you distribute the multiplication to each term inside. So, a times b plus c becomes ab plus ac. These are the building blocks of algebra, and they hold true for all real numbers. Let's not forget about roots, square roots, cube roots, and more. Here's the rule. You can only take even roots, like square roots, of positive real numbers if you want to stay in the real number system. So square root of 4? That's 2, totally fine. But square root of minus 4? Aha! That's not a real number. So just remember, Stay positive when working with square roots. Here's what we learned today. Real numbers include both rational and irrational numbers. Rational numbers are closed under addition, subtraction, multiplication, and division, easy. But irrational numbers, not so predictable. Sometimes the result is still irrational. Other times, it turns out rational. Mixing the two, the irrational part usually takes over. And no matter what, the laws of arithmetic, commutative, associative, and distributive always hold true. Just remember, square roots work only for positive real numbers, or you leave the real number system entirely.